Friends, welcome to the class. Today we'll discuss about decimal expansion of rational numbers. The decimal expansion of every rational number is either terminating or non-terminating repeating. Now let us understand what is this terminating and non-terminating repeating. Terminating decimal expansion. The number which terminates or ends completely after a finite number of steps in the process of division is called terminating decimal expansion. For example, 2.25, 3.17. That means, what does it mean? The example shows that after this 0.25, there is no further expansion. That means the division stopped after 0.25. Similarly, in the second case, after 0.17, the division stopped. So this is terminating decimal expansion. Non-terminating decimal expansion, the number which does not terminate in the process of division is said to be non-terminating decimal expansion. It is of two types. Non-terminating repeating expansion, the number which does not terminate but repeats the particular number again and again in the process of division is called non-terminating repeating expansion or non-terminating repeating decimal. For example, if we divide 1 by 3, 1 by 3 is 0.333, it continues, so we can write it as 0.3 bar. So the decimal expansion of this type of number is shown by putting a bar over the repeating digits. In the above example, 3 is repeating, so we put bar over it. Now let's see another type of non-terminating decimal expansion. Non-terminating, non-repeating decimal expansion, the number which neither terminates nor repeats the particular number in the process of division, is called a non-terminating, non-repeating decimal expansion. These numbers are called irrational numbers. For example, 1.23150235128 and so on, or square root of 7, square root of 3, etc. This comes under non-terminating repeating decimal expansion. Let us understand the different component of decimal expansion, and this can be represented by the following flowchart. Decimal expansion, it is of two types, terminating and non-terminating decimal expansion. Again, non-terminating decimal expansion further divided into two parts, non-terminating repeating and non-terminating non-repeating. If we go further, terminating decimal gives rational numbers and non-terminating, non-repeating decimal expansion gives irrational numbers. And this rational number and irrational number, they put together constitute real numbers. However, in this case, few things we need to note, we need to remember. For example, if x and y are two distinct rational numbers, then x plus y whole divided by 2 is a rational number between them. And if x and y are two distinct irrational numbers, then square root of xy is an irrational number between them. If we add or subtract any irrational number to any irrational number, the answer may be rational or irrational. If we multiply or divide an irrational number by any irrational number, then the answer must be rational or irrational. If we multiply any rational number by another non-zero rational number, then the answer will always be rational. Let's go through some examples. Check whether the rational number 1 by 13 has a terminating, recurring or non-terminating decimal expansion. So the given number is 1 by 13. The prime factors of 13 are not of the form 2 to the power n, 5 to the power n. So 1 by 13 has non-terminating decimal expansion. See, to get a terminating decimal expansion, we need to have multiple of 10 in the denominator. That means multiple of 2 and 5 put together. Since the prime factors of 13 is not of the form 2 to the power n, 5 to the power m, that means it is clear that the prime factorization of 13 does not contain 10. Therefore, 1 by 13 has non-terminating decimal expansion. Now 1 by 13 equals to 0.13. 769,230, 769,230 and so on. Thus 1 by 13 has non-terminating repeating decimal expansion. The decimal expansion of rational numbers 43 by 2 to the power 4, 5 to the power 3 will terminate after how many places of decimal? So the given number is 43 by 2 to the power 4 into 5 to the power 3, or it can be written as 43 by 2 to the power 4, 5 to the power 3 equals to 43 by 2 to the power 4, 5 to the power 3 into 5 into 5 by 5. That means we are multiplying 5 in both numerator and denominator, or it can be written as 43 into 5 whole divided by 2 to the power 4 into 5 to the power 4, which is equals to 0.0215. That means after decimal we are getting 4 digits. Thus the decimal expansion will terminate after 4 places. Let's see another example. If 453 by 2000 equals to 453 by 2 to the power m 5 to the power n, find the value of m and n, write the decimal expansion without actual division. The given number is 453 by 2000, which is equals to 453 by 2 to the power m 5 to the power n, but 453 by 2000 equals to 453 by 2 to the power 4 into 5 to the power 3. So we can write it as 453 by 2000 equals to 453 by 2 to the power m into 5 to the power n, and this implies m equals to 4 and equals to 3. Here in both the cases, numerator is same in both the cases. So if we equate the denominator, the power of 2 is 4 and power of 5 is 3. That's why m is 4 and n is 3. And 453 by 2000 equals to 0.2265. So m equals to 4 and n equals to 3, and the decimal expansion is 0.2265. This is the answer. Friends, here is a few questions. The more and more questions you practice, the easier it becomes and the more you like it. And in case you come across any difficult questions, do share your question with me. It will be a pleasure for me if I can help you out in solving your doubts, in solving your questions. So this much for today's class. Thank you.